My name's John Russo, and it's my pleasure to welcome Aaron Bassett, who's going to talk about introducing the farm stack with FastAPI, React, and MongoDB. Aaron Bassett's lived in Ireland, Scotland, Hungary, and the Netherlands, and he's this recovering senior software engineer turned award-winning developer advocate. As a developer, public speaker, writer, and mentor, he spends most of his time making cool stuff and helping other people make unbelievably cool stuff. Aaron's been working online since 2005 and has always enjoyed sharing what he learned by organizing and speaking at local meetups. He spoke at his first conference in 2013, and since then he's spoken at conferences on a range of topics all over the world. He has a passion for mentoring and has been involved with Social Innovation Camp UK, Social Innovation Camp Kosovo, Startup Weekend, Open Glasgow, Django Girls, and Global Diversity CFP Day.
That intro seems a lot longer when it's read out than when it's on my website, to be honest. But thank you so much for going through all of that. Yeah, it'll take me a little bit now to compose myself and to get the embarrassment out of the way. But yeah, so I think I'll probably get started then. We are going to have a very quick introduction. In this 30-minute session, we're going to go through a complete stack. So from server side to data persistence, and then obviously rendering the client side as well. So one thing I do want to highlight first is I have a gist, which is available at this URL. So that's, I'll read it out, is git.io/J, lowercase t, capital S, lowercase h, capital S. So I'll leave that on the screen for a second. That's going to take you to a gist where I've outlined, where I've listed a lot of different links, links to like the repository for the code that we're going to go through today, for my socials where I'll send out more information out as well. I've also written this up as a tutorial previously, so there is a link to the tutorial there, and I've also streamed about it in the past as well on Twitch, so I've included links to those too, and you'll find that in this gist. So there's those kind of links. One thing I do want to point out is because it is so fast today, and I know I speak pretty quickly and I hopefully won't lose anybody, but if I do, what I'm going to do as well is I will stream about the farm stack on my Twitch channel. I stream on Twitch pretty much every day, normally programming Python, but I will make sure I do a stream on Tuesday at 2 p.m. EST about farm stack, just so I can go into a little bit more detail, and also any questions I don't get to answer at today's conference or anything you want me to do a deeper dive into, then we can talk on Twitch and I can hopefully explain it there as well. So I just wanted to really pull that out, and if you're available on Tuesday, please do shoot in. Okay, so that's all out of the way. Now we're going to look at the farm stack. So as mentioned, it is made up of FastAPI. So FastAPI is a async server for Python, and that's what's going to be doing our yaw routing. It's going to be have our different views there. It's going to interact with our persistence layer. Our persistence layer is going to be the M in farm stack, which is going to be MongoDB. We're going to be using MongoDB with Motor, which is their async, so their unblocking client as well. And then on the R farm stack is going to be React. So that's how we're going to render our front end. Now I'm going to hop a little bit to the end of our acronym here. And obviously, like all good stacks need a good acronym. So I'm quite pleased with farm. But the MongoDB part, I'm actually going to use MongoDB's Atlas. So Atlas is their managed hosted service in the cloud. And I'm going to do that just for ease of use, to be honest. So I don't need to take you through setting up a MongoDB cluster on my local machine or how to install MongoDB or anything like that. All this stuff will work with the self-hosted version of Mongo. I'm not doing anything that requires Atlas. I'm just going to use Atlas for ease of setup for myself. So I'm going to start up building a free cluster just now. And then we will look at some of the code while this builds, because it can take a little moment to actually do that. Okay, so I'm going to leave this to deploying a new cluster. And we're going to go look at, so I have in the source code repository, I've tried to break the commits down to make it pretty easy to follow. So I'm just going to check out each commit in turn, and we can walk through and kind of build it up bit by bit. Starting in the back end with the FastAPI, connecting to our MongoDB, connecting to our persistence layer, Then we'll create our CRUD views. And then once we've done that, then we'll go into the front end and we'll look at how we can link that all up with React to render it in the browser. So I already have this cloned. I've checked out one of the very first commits, this create backend structure. And let's just go have a look at the actual structure of it. So this is probably going to be a little bit small of a side. Apologies for this, but we have a backend folder. In fact, I can probably look at it in the browser. It might be easier for you. Just make it a little bit bigger. So in the backend, we have a main.py, which is going to host our actual FastAPI app. We've got some requirements. We can see here I'm specifying kind of FastAPI, UVcorn, which is our ASGI server, Pydantic, which is going to we're going to be using for our models and for our data validation, and then Motor and DNS Python. So Motor is the async MongoDB client. DNS Python is really just a utility to allow me to use connection strings for connecting to MongoDB, so I can specify the full connection path in a single string rather than having to break it out into database like host, port, etc., etc. And then Black and Flake8, because I use them pretty much every project. So that's our requirements. And then the rest of our structure, I said I'm just going to have a single app, which is going to be a to-do app, because that's like the basic app we create for everything. And within the to-do app, we're going to have some models and we're going to have some roots. So that's the basic structure of the back end. We won't worry about the front end just now. I do things like config, where we're going to set up, what the name of our app is, where it should be in debug mode, our server settings, where it should be hosted on what port, etc. Really kind of common stuff. So now we looked at the structure. I'm just going to check out my main branch again, and we're going to skip forward a little bit to connecting to our connecting to our database layer, to our persistence layer. So in our main.py is where we're going to connect to our MongoDB instance. So you can see at the top, I am importing our async IO Motor client, and I have these two decorators for two different events. The first decorator is our startup event. So this is going to be triggered whenever the app starts up. And it is creating a new MongoDB client. And then it's adding that as an attribute to our FastAPI app. And the reason we're doing this is so that it's available later on within our views. So we have the MongoDB client as being attached to the app, and also MongoDB, which is a reference just to the database itself. Then in our next event, which is a shutdown event, we're just doing some cleanup, some housekeeping. And you can see here we've got our MongoDB client, and we're just closing that whenever the app shuts down. And then finally, we have just our UVcorn run, which is going to be running our app. And we can see some of those settings that we looked at briefly here coming in, which host it should be on. The reload will do an automatic reload if we're in debug mode. So if I make any code changes, it's going to automatically binds the server for me, and then things like our port as well. So now we have this, we'll connect to MongoDB. We need to look at how we actually structure our data. So again, let's just check out our main so I can get models. So here we go. I know talking about, you might hear me say there that we're going to look at the models. And for a lot of people, whenever they think of MongoDB, they think of it as not really having a structure, of being schemaless. And that is true. MongoDB doesn't require any kind of data schema. But a lot of times you will want to still use models with it, so you can enforce things or do validation and enforce different kind of data structures. So in our apps now, we have our, in our to-do, we have our models here. And within our models, we're going to define two different ones. And I'll explain why in just a second. So we have a basic task model, which is what's going to hold the different tasks for our to-do app. And within the task model, we have three different attributes. Now, name is pretty self-explanatory. It's going to be the name of the task, or the title of the task, and it's a string. We specify it with the field and this ellipse, just to show that we don't want to give it a default value, but we do want it to be required. We have it completed, so we can mark whenever a task in our to-do list has been done, and that's going to default to false. And then we have this ID. And this is something that's worth noting, is in MongoDB, if you do not specify an ID for a document, it will automatically set one. And it'll set it off a type of object called an object ID. Now, MongoDB is, as much people assume that it, or think it's a JSON store, it's not. It's actually a BSON store. It's binary JSON, which is a superset of JSON that includes different data types that are not normally available, or sorry, are not available in JSON. And one of those data types is an object ID. And that's their kind of default for IDs in MongoDB. Because it's not something that's a native JSON type, whenever you come to serialize and deserialize it, your normal JSON serializers won't be able to, they don't know how to handle it. So I could write a custom serializer for it, or I can specify my own ID. And that's what I'm doing here, is I'm saying that my ID field is going to be a type string, and that I'm just going to use the default of a UUID for it. You also see that I'm specifying ID, whereas MongoDB actually calls their IDs underscore ID. Now I can't do underscore ID here, because then Pydantic is going to think that that is a private attribute, and it's not going to include it in my model. So we remove that. We do have to remember, though, if we are doing this kind of aliasing of attribute names or field names, that we need to set this allow population by field name to be true. So that means that we can set it both by this alias and by just our field name of ID. The schema extra is going to be used for documentation in a second. I'll show you that. Now, we also have this update task model. And the reason we have the two models here is whenever we are updating our tasks, we don't want to be able to set the ID. We shouldn't be able to change that. You know, if we're updating the task itself, the ID should remain as it was. We may want to update the name, and we probably definitely want to be able to update the status of it, whether the task is being completed or not. So both of those are on this model as things that can be modified, but they're both set to optional as well. So we don't have to supply a name. We could supply our updated model with just the completed status changing. Or by the same token, if we made a typo in our name, but we don't want to mark it as completed yet, we don't need to specify the completed. We could just change the name. And again, we have the schema extra to show what is available on the API. So with this model, I'm just going to make sure I'm not making any changes so I can do my git checkout here. Now we have our model. We need to link it up to some roots. So let's check ID correct commit for that. Here we go, creating our Crud Roots. So anybody who's not heard the term Crud before, it refers to create, read, update, delete. It's a common name for the most common kind of API roots that you'll receive. You know, you want to be able to create new objects, read those objects, so either get the details of a single object or a list of objects, update an object, and delete. So it's pretty much the different REST API endpoints you would have. And these are now in this field or in this file called rooters. And if we look at it, you can see I'm importing those models I've just defined, and then I have multiple different rooters that I'm defining. One for post, two for get, one for put, and one for delete. And these all map to those different CRUD endpoints. So our create is our post. So anytime we're sending a post request, that means we're going to be creating a new task. And we can see that our post request receives a task model, which is going to be set to the body of the request. So we're going to send in a JSON string as the body of our request. It creates a new task, and then it writes that task into MongoDB. And here's where we have that MongoDB database that we created on our app earlier. So we can now reference the app as part of the request in FastAPI. So here we're inserting our task. We're using await because we're using the async client. And then once it's inserted, what MongoDB will actually return is an inserted ID. So we then fetch the newly created task from the database again, and then we return that as part of our JSON response with a HTTP 201. Our gets are very similar. We have, if you get without passing in any arguments, it's going to get a list of all of tasks. So here we can see we're just doing a find, and then we're converting that to a list, and we're returning it. If we supply an ID of a task as part of the URL, then we know we only want to show that one task. So in our request handler here. We see the ID is getting passed in as an argument to our handler. And then we're using a lovely walrus operator here to say that task is going to be this MongoDB request where we find find one based upon the ID equal to ID. And as long as that returns, as long as that's not none, so we find a matching value, we will return that task. If we can't find a matching value, then we're going to raise an exception with a 404 and say the task wasn't found. Put is kind of a combination of the two, our create and our get here, in that because of put is updating a single task, it requires the ID, so it's getting passed in the URL again, and then we have this update task model. So this is again, it's going to be set from the body, and then we are ensuring that we have some new values that we want to set. We're doing a update one instead of our find one. And our update one takes a query as the first parameter to find the correct record to update, and then what we want to do afterwards. In this case, we want to set some fields to be equal to the new task that was passed in. Like a create, it doesn't return the document. Instead, it returns a update results, which will have a modified count. If that's equal to 1, then we're going to try and find that task we just updated, and then we're going to return it. If for whatever reason we didn't actually send any fields to update, then we'll just try and find the task. And if we get to this point and we haven't found a updated task, nor have we found an existing task, then we just 404. And finally, delete, again, is only operating on a single task. So it requires an ID. And in this instance, we are just calling delete one, checking that the deleted count is equal to 1. And if it is, returning a status code of 204. So 204 is basically saying that everything went well, that everything succeeded correctly, but I don't have any content to send you back because we just deleted it. So it's like a 200, but with no response body. And again, if we don't get a deleted count of 1, then we can assume that we couldn't find a record, and we just return a 404. So now we have our roots, and we have our models, and we have our main app configured, where it's actually connecting to our MongoDB. We should be able to start up our server. So I'm just going to check out main again. Sure our roots are added in, which is going to be this one. And now I can start the server. So to start the server, I'm going to just cd into the backend, which are already in. Great. I can just run Python main. Okay, so now we have our server up and running at port 8000. And I should be able to take a look at that in my browser. And I can go to /docs, and it's going to give me this lovely generated documentation. I didn't need to do anything extra for this. It's generated by itself. So I can go in, I can list tasks. So I've already created a couple of tasks here in the database. We can see I can create a new task. So I'm going to try it out. Let me see now. I'm not going to specify an ID. I'll let it auto-generate the ID for me. I'm going to be, in my task here, I'm going to be like, give PyCascades demo and completed false. Yep, that's perfect. So we're going to execute that. We can see here I get my 201 back, which is the correct status code. And we can see I've got the response body with my newly created task. So I'm just going to grab this ID so we can work with it a little bit more. I can show an individual task by supplying that ID. So there's the task I just created. I can update the task. Again, let's put the ID in here. And I'm going to update my completed status to true. I know it's not quite ready because we're not fully finished the demo, but we're going to make it true anyway. So here we go. My completed status is now true. Let's bump it up a bit so people can see it a little better. And then finally, we have our delete. And if I pop the ID of that same task, and we can see we get a 204, but there's no body, which is what we expected. So that has now been deleted. If I go back up to my list tasks and execute, I can see I only have those 2 that I previously created in there. If I do my get, which should be down here somewhere. Yeah, so task with that ID, and I try this now, we get our 404. And this lovely interactive documentation is all created for us by FastAPI. So that's the Python side of it done. I know it's really, really quick. We ran through it pretty fast there. But hopefully that gives you a flavor of just how quickly you can create a API with FastAPI. Like, it's not called FastAPI for nothing, I guess, and get this really kind of interactive documentation. Also, I should point out the things like, let's just cancel this so you can see. So here where we're getting, the request body and the schema and stuff, this is all like where I was specifying in the models before. It's this example schema. So whenever I went to, let's reset it and try it out. So this is the example value here you can see, which matches this example value here. So this is where you can define some of these additional fields that will then show in your interactive documentation. For the front end, I'm going to leave this server running. I'm going to start a new terminal. Let's just move back into my project, farm. Okay, so let's check our main branch again so we can view our log. And we're just going to add a static React layout. So to create the React part of it, I just use create React app. There's nothing custom here at all. For anybody who's used any kind of React before, it is just the same command as you always use. Would be like npx create React app, and then the app name, which I just called front end in this case, which gave me the files we're going to look at in a second. So I now have this front end folder was created with create React app. And I've already installed all my dependencies and things in here. So let's go look in front end. And we see we have this app.js. And this is just a static layout at the moment. So I'm going to do my npm start. That's going to start my front end server. Oh, hopefully. If I was in the correct directory. There we go. So now I have two servers running. We have the FastAPI server, which is serving up our backend here. And then we also have a React server, which is going to be serving up our front end code. I'm just going to bring this over here so we can see it in this one too. Okay, so this is just purely static at the minute. Doesn't do anything. It's not adding things in. This is not our correct task name, etc. It doesn't do anything at all. This is just statically rendered HTML from a React app. And we can see that here. So we have, I'm using Ant Design or to allow me to lay out some of my components a little better. But essentially, we have a grid system where we've got two columns. The first column has got a form within it. That form has a single input, which is our input here, and it has a button. And then on the other side, we have what they refer to as a timeline. So a timeline, I'll add an extra item in so you can see, just does this kind of thing here. So I'm using it to display the tasks on a timeline. It's just something that's built into Ant Design. It's one of the components they give you. So I'm going to take this back out so I can start adding in some of the interactive elements. Don't save that because it's going. I need to stash it otherwise. I need another new terminal. Oh, and cd into my projects directory again. Okay, and let's just check out our. Oh, I must have some more changes. Let's just stash them. There we go. Okay, so that was our last one, was the static React layout. So now we're going to fetch the items from the server. So I'm going to go back and look at the front-end codes that we had now. So let's close out our models.py and go look at our front ends. In our app.js, we now have a couple of what they call hooks. That's what these use effects are. They're hooks. We also have a few things that we're storing in the state of the app. So we have tasks and timeline. Tasks is going to be the tasks that we're fetching from the database, and timeline is going to be those timeline elements that are going to be rendered out of the tasks. So our first hook just runs whenever the component is first loaded, and it's going to fetch all tasks. Now, we put it in this wrapper because you can't do an async call directly within a hook. Sorry, you can't do an await directly within a hook. We have to be within an async function. So I create this other function called fetch all tasks that's going to wrap our code for us. And in here, we just do a get request against that task endpoint. And we know that a single GET request without specifying an ID is going to return us all of the tasks. Then we turn that JSON string we receive back from our API server back into an object, and we store it in this tasks variable. Then we have another hook, and this hook is actually, it's monitoring that task variable. So this hook will be run anytime this variable changes or is updated. And what it's going to do is it runs this map over the tasks, and it creates these timeline items. So we're first checking to see if the task has been completed, and if it has, then we output our timeline item with a stroke through it, and we mark it as green. If it's not being completed, more or less the same components, except we do not have the line through, and we're coloring it blue. So if we save this now and go look at our front end, we might need to refresh it actually. Oh, sorry, we need to actually restart the app. Sorry, let's just close that. The reason I need to restart the app is because our front end is running on port 3000, but our back end is running on port 8000. We are actually going to proxy between the two, and that's this line at the bottom of my package.json. So it knows that whenever I'm making this request to task, that it shouldn't be localhost 3000/task. It should be proxied to 8000. But because I modified my package.json, I had to restart the server. And here we can see then that we now have these to-do items are appearing in the front end. So if I go back to my Swagger UI and I create a new task, let's try it out again. Again, let's take out the ID. We're going to let it set it. We're going to do, demo front end and completed false. Perfect. We're going to execute that. Got it back. And if we go look at our React app, demo front end has now appeared as well. So that's a really, really quick run through off this. I do want to just show you as well that it's pretty, there is also put in here, sorry, to do, if I check out our main again, to deletion and updating cascade status. We're going to jump forward to those. Let's just jump forward to, let's just use main actually. It's going to have everything in here. So now if you look at our apps JSON, we can see my dog's telling me I'm at time, if you can hear him in the background. That we have tasks for saving our tasks and changing status, etc. So now if I go back to my front end, I can go like new task, add it. It's going to appear in here as well. So that's, again, just hitting our task endpoint, but this time with a post rather than a get. And we're sending the data from our form here as our new to-do. And then for the little buttons beside it here, so I can take these to change the status. We're using that put that we had before. So here we got to change task status, this time with a task ID and a HTTP method of put. And we're sending that to the server. And then finally, we have these little red ones, which is going to be our deletes. So I'm going to click a couple of those. And those are linked to this delete task method. And that's going to, again, use just like our task endpoint with the ID, but we're setting a method of delete. So that's kind of the entire farm stack. As I said, it is a very, very quick run through. Trying to do a full stack from server and data persistence to front end in 30 minutes is a little bit of a push. I will go through it in a lot more detail on Tuesday. I promise you, if you tune into my Twitch channel at 2 p.m. Eastern time, I will spend a lot more time going through this code. We might try to add some additional stuff to it. Let's see if we can get some authentication added in, so not just anybody can go in and create new to-dos for us, or delete to-dos. So we have them marked next to a particular user and stuff. We can try and get that running on Tuesday as well. And also give you an opportunity. I know there's not an awful lot of interaction here. I should be more interactive on the stream, so you can ask me some questions about it as well. But with that said, I will be about for the rest of the conference on the on Benulous to be there to answer your questions and things as well. So thank you very much, and hey, welcome back. Oh, I can't hear you. I don't know if is my mic off or is my headphones off or your mic off? I'm hoping it's my headphones. I'm still not getting any audio.
I can confirm there's no audio. This is just Chris the Tech here.
Okay.
But I'll read John's lips and say thank you very much. That was super interesting, much appreciated. And
I wasn't sure it was like I was getting questions or anything. I was like, oh, I don't know. I hope he doesn't think I'm just ignoring him.
Amazing.
The
thank you very
joys
much.
of online conferences.
We love it. We all love it. Yeah, absolutely. And you'll be hanging out at Venulus for a little bit?
I will indeed, yeah.
Excellent. So any questions, pop them there and stick around, people, because we have a wonderful presentation coming up next titled, What Do You Get When You Combine a Snake, a Squirrel, and a Squirrel, I should say. We shall find out shortly. Thanks everyone, and have a good one.